you very much. Let's have a look at this question. This question is related to the frosting of a cone. And some students find it difficult, but it's very easy. So I will give a lot of questions on that so that your understanding of how to calculate the frosting of a cone will be heightened. Now the question says that a hollow right circular cone stands with its base on a horizontal table and it is 100 centimeters high with a base radius of 20 centimeters. It is filled with water through the vertex up to a depth of 25 centimeters. Calculate I, the radius of the circle formed by the water surface. I, the volume of the water inside the cone, correct to the nearest whole number. Okay, good. This is the cone with the base on a table. So let's say a table is there and this cone is sitting with its base comfortably on the table. And we are told that it is 100 centimeters high. So the height of the cone is 100 centimeters. 100 centimeters. That's the cone. So the height 100 centimeters. With a base radius of 20 centimeters, with a base radius, so they are talking about the cone, with a base radius. This base radius R is equal to 20 centimeters. Let me make this one capital R. The radius of the cone, 20 centimeters. It is filled with water through the vertex. This is the vertex, V. So let me write here V. Through the vertex, V, it is filled. Maybe there's a hole here. So the cone is filled with water through the vertex up to a depth of 25 centimeters. So if you are filling, it will increase from down to the top. And also, the volume of water will increase from down to top. So let's say it was filled up to this level. Let's say for instance, up to this level. From down, the height of the cone is 25 centimeters. That's the whole of this is 25. Is it 100 centimeters? 100 centimeters. And it is filled up to a level which is 25 centimeters. So it is filled up to this level. So 25 centimeters here. It's filled up to this level. And the whole height is 100 and then it is filled up to 25 centimeters. You see that? Do you see that? He said 25 centimeters, the vertex up to a depth of 25 centimeters. So 25 centimeters is the depth at which the water has been filled up to. So let's say this is how we weigh. So when you fill water in a cylinder or a bucket, the surface of it is curved, is circular. The surface of water. So this is the circular part of the surface of the water. And you see, the cone has a height. The cone has a height. And this is the height of the cone, which is 100 centimeters, yes. So this height of the cone is 100 centimeters. And at every point in time, when there's a circle formed, the radius is perpendicular to the height. So this is a small circle. This is an arrow. That is why I made here capital arrow, because the circle formed at the level of the water, which has been filled, will have a radius, and the radius is small r. Small r. That's to give a differentiation to both the radius of the cylinder itself and the radius of the circular part of this water surface. So that is it. The water is formed at this point. And in fact, the height is this. So from this point to this side, you see, from where the water is 25 centimeters. Not so. And from this V to this side is 100 centimeters. So obviously, from this side, from from the top here, from the top here, this small h, let's make this small h. You see, when you pick V, look at it carefully. Here, V, A, B, C, D. Look at it. So we have V, A, B. V, A, B. I've written here A. From the height upward will be, because the whole height is 100 centimeters. And from this place to this place is 25. So obviously, here will be 75, not so? So 75 plus 25 will give us 100. So let me pick this VCR out, that triangle. You see that it will be like this. With this part. Here will be V, A, B, C, D. With here the radius 100 centimeters, 20 centimeters also, 20 centimeters. We see that here is forming the radius. You see that. Now, the AB, which is also a radius for a small circle, is not known. So I'll write a small r, and this capital R. Now, from this side to this side, which is where the water was filled up to, is 25 centimeters. From this place to that place will be 75 centimeters. Because you subtract 25 from 100, you get 75. And the whole height becomes 100 centimeters. 100 centimeters. Now what you have to do, you have to calculate for the radius. Because the reason being that if we are asked to calculate for, it said the radius of the circle formed on the water surface, which is the small r here. That's why it is in the question. So look, this triangle, look at this triangle. When we pick triangle VAB and triangle VCD, these triangles are similar. They are similar. These triangles are similar. We call them similar triangles. That's triangle VAB is similar to triangle VCB. Let me draw this one, you see properly. V is here, A is here, 75 centimeters is here, R is here. Then the bigger triangle. We have this, we have V, C, D. Here being 20 centimeters. Here, 100 centimeters. Then let's see, why are they similar? Do you know this angle, V here, is equal to this angle, V. Do you see that? This angle here, 90 degrees, is equal to this angle here. So obviously the angle here will be equal to the angle here. So if you have a triangle which has, every triangle has 3 interior angles. If the interior angles of a particular triangle is equal to the interior angle of another triangle, those two triangles are similar. And the ratio of their corresponding sides are equal. So we shall use that. Now that we have been able to know that they are similar from properties of similar triangles, that this angle, because if you have AVB, you see here is V and they say V is here, so they say here is 90 degrees, here is also 90 degrees. Obviously if this angle and this angle, this and that and that are equal, so definitely this and that will be equal. So for example, if here is 60, here is 90, here is 60, here is 90, If you add and subtract from 180, what you get here is the same thing that you get for this. So the three angles are equal, so or the same, and therefore the two triangles are similar. If they are similar, let's go to the ratio of their side. It is how you pick them. I will pick the smaller one first. If I pick the smaller one first, AB, look at the AB. R over AB should be over CD. You see that the radius, which is 20, is equal to, you see, I've been picking this one first. So you should go consistency. I'll pick this side, 75 over 100, this side. You see that? So what you do is that, let me tell you why I did that. This one is equal to this side. This side is equal to this side. So the sides that are equal, the opposite sides. You see this one, the opposite side is this. This one is opposite side is this. So it should be R over 20 is equal to their corresponding sides. You see this side is equal to that. And this side, I pick here first, so I have to go to a smaller triangle also. You see, this side is equal to this, and opposite of this side is 75. And that angle which is equal to this, what is this opposite side? 100. Now, this will be 100 times R, which is 100 R is equal to 20 times what? 75. Then we divide through by 100 by 100. This cancels this, and R is equal to 20 times 75 divided by 100. Obviously, it will give us 15 centimeters. That is the radius of the circle. That's the radius of the circle on the formed by the water on the surface of the cone. So this R is 15 centimeters. Very simple as that. The second one is that we should calculate for the volume of the water. This one is the height of the water, not volume. So one thing you should understand is that when we are calculating for volume of the water like this, you see, it's like, you see the whole cone. When you consider, it is filled up to this side also. So to get the volume of the cone inside will be the volume of the whole cone minus the volume of the top. When you subtract top from it, the remaining is be the one at the down. You see that the volume of the whole cone. Let's say, for instance, if the volume of the whole cone is, let's say if I have calculated the volume of the bigger cone, it has given us 50 centimeters cube. Not so. And the top, when we calculate the volume of the top, it also gave us 20 centimeters cube. You see that? What will be the volume of the down? It will be 50 minus 20, which will be 30 centimeters cube. So it is a matter of knowing the volume of the total cone. Then the top one, if you remove the top one, because let's say, if I cut off the volume, the cone upwards, whatever is left is for the down. So if the volume of the total cone is 50 centimeters cube and the volume of the top is 20 centimeters cube, obviously the volume of the down from this side to this side will be 30 centimeters cube, because I will subtract the top one from the whole cone, whatever is left is for the down. So that is what you should do. So I can clean this one. Since we have been able to calculate for our radius, and our radius is 15 centimeters. So the volume of the water inside the cone will be 1/3, because I'm calculating the volume of the whole cone will be 1/3 pi r squared h. Because I'll make it h because this one too has height. And the height of the whole cone, which is what? 100. Not so. This one will be the height of the whole cone, 100 centimeters. This will be the height, or it is written here, so this 100 centimeters. should be equal to h, because we have the height of the smaller cone at the top. You see the cones are 2. If you pick the top, it's a cone, and the whole of this is a cone. So to differentiate, minus the smaller cone 1/3 pi r squared h, which is the smaller height. Now, looking at it carefully, I can factorize 1/3 pi out. So it should be v is equal to 1/3 pi out. You shall have r squared times h, r squared h, minus pi minus small r squared h. This is what we have. So v is equal to 1/3 times 22/7. 1/3 times 5, which is 22/7. Let me stand here so that you can see properly. 1/3 times. I factorize 1/3 pi from both sides, and I have this. That's the explanation. And pi is 22/7, giving the question. So the arrow is 20. 20 squared, which is 400. 20 squared times the height, which is 100, minus the radius, which we calculated here, 15, the small arrow, squared times the height. Small h is what? The h, which gave us 75. So this h is equal to 75, because the whole of it is 100, and it was filled up to 25 centimeters height here, from the point the red mark is 25. So the rest will be 75. So times 75. This one will give me 22/21 multiply. This one will give me 400. 400 times 100 will give me 4,000 also. 40,000. 40,000. 40,000 minus 15 square times 75.
16,875.
875. Good. Not so. So V is equal to that. Now V is equal to, subtract this, what do you get?
23,000.
So 2 times 2 3 2 3
is 23,000. The answer is 23,000.
When you subtract this,
yes,
you get 2 3
125.
125. That's all. Over 21, because this will multiply that over 21, and V finally will be equal to
24,000.
226.
226. Yes. 0.19.
0.19. I always want you to read it because we have points inside. So it should be 24226.19. So I always want to read it off. 24,226. It should be 24226. So when you have 3, 4, 5, we don't say 0.92. We don't say 345.92. 345.92. That's why I prefer you reading it. So V will be equal to 24226, not so, centimeters cubed. And that is the volume of water in the container. That's the volume. So the volume of the water is 24226. Now, as for now, you can say 24,226 centimeters cubed, because there's no dot, and so that is right. That's our calculation. So this is how to go about questions like this. Let me quickly give another question, which was asked in SSE. That's also very simple. It's similar. It was drawn like this for the students to solve. Very simple like this. The question says that the figure shows a cone whose upper part has been cut off. The base radius is 6 centimeters and the upper radius is 3 centimeters. If the height of the cone and the remaining portion is 4 centimeters, calculate correct to the nearest whole number. The volume of the original cone and the volume of the remaining portion. That's great. So this information given to us is about cone. And the question is saying that we should calculate for the volume of the original cone and the volume of the remaining portion. So if this is how it has been given to us, look at the drawing carefully. Look at the drawing carefully. I will continue with the drawing. So this is it. So to get the volume of the remaining parts, we should continue to form the whole cone. As I did. So I will come and draw the whole cone here. So this, in the initial stage, this is the question given to us. And the height of the cone is this. It has been cut. So in some questions, they will not say it's a cone. They can say even it's a bucket filled with water to this height. So bucket, you know bucket. In that case, if it is bucket, you see how bucket looks like. Bucket looks like this. So it will be like this. Because bucket, the top is open, so much more than the down. So you continue like this to form a cone down. So that if you subtract this one from the whole volume, you will get the volume of the bucket. That is how it is. Now, with this one, we continue. You continue like this. So, this one will have a height. You see that? The whole height. Let the whole height be capital H. So look at the whole height, capital H. You see the height of if this one is small h, the small h, from the top here, let's make it here O, A, B, C, D. You see that triangle OAB has height, and from C to A is 4 centimeters. So the whole height of the bigger triangle OCD will be 8 plus what? 4. 8 plus 4. So if I come to this side to calculate it, if I come to this side, I will redraw it. This is 6 centimeters, 3 centimeters. Yes, A, O, B, C, D. So you see that we have two similar triangles again. And the whole height, this is the height, which will be this H here from C to A is 4 centimeters. It has been given the question 4 centimeters. And here is H. So the whole height from O to C will be 4 plus H. The 4 plus H. Now, this is a right triangle. This is a right triangle. So, just as we did, 3 over what? 3. I'll pick the triangle at the top first. Should be 3 divided by 3 is equal to h small h over 4 plus h. 4 plus h. You see that over this whole height. And this one will give me 3 multiply 4 plus h also is equal to 6h. So this will give me 12 plus 3h, which is equal to 6h. So this 12 is equal to 6h minus 3h. 12. Let me you see that I'm going to now. This will give me 12 is equal to 6h minus 3h. 12 is equal to what? 3h. You divide both by 3, you get h is equal to 4 centimeters. So look at that height and this height are divided. If it is water that they are filling, if it is water, mean that they fill up to half. Because when you calculate h, that one is also 4 centimeters. And from C to A is also 4 centimeters. Meaning that the whole height will be the capital H from this side to this side, H, which equals to 8 centimeters. Now, how do we calculate for the volume of the bigger cone? Volume of the bigger cone will be V is equal to 1/3 pi capital R squared. So this one, let's make this one capital R. This one small r. This one small r. This one capital R. So V will be equal to 1/3 times pi 22/7 times the radius, which is 6. Oh, it should be 1/3 pi r squared each. The radius is what? 6 squared, and the height is 8, not so, which we have calculated here. So, okay, now take the calculator, press 1/3 times 22/7 times 36 times 8, which is 1/3 times 22/7 times 6 squared will give us 36 times 8. So the volume will be equal to 3017. And that becomes the volume of the whole cone. The volume of the whole cone. After that, we go to the volume of the top of the cone, the top section of the cone. So if you want the volume of the down, the first two, if you remove the top, what remains? Then it will be subtraction of the top cone from the total cone. What remains will be for the down part. So V should be 1/3 times, we press 22 times 36 times 8. Then divide the answer by
301.71.
301.7142. So approximately equals to 301.7 centimeters cube. And that will be the volume for the bigger cone also. Now the volume for the smaller cone, V will be equal to 1/3 pi r squared h. That's, we see that the height of the bigger cone differs from the height of the smaller cone, and the radius also differs from the radius of the smaller cone. So I'm using the capital H and the capital R to give that differentiation. So V will be equal to 1/3 times 22/7 times the radius, which is 3 squared, times the height, which we calculated for. We had 4 centimeters. So V will be equal to 22 times 9 times 4 over 21. Because 1 times 22 gives us 22. Times 3 squared, which is 9, times 4, which is here. All over 3 times 7, which is 21. And the volume will be equal to 37.7142. So volume is approximately equal to 37.7 centimeters cube. The unit is very important. So now, if you are asked to calculate for the dam, if it is water that is filled or sand, and you are asked to calculate for that part that has been filled, it would have been V. Let's say this one, the original cone is V1. Also, and the top part of the cone V2. It should be V1 minus V2, which will give the volume of the water in or any object at all that remains. But this one, it should be water. Even if the sand is still be circular on the surface, volume of the water or liquid inside. So it will be 301.7 minus 37.7, and that will give us what?
264.
264.
Finish.
That's all.
Yes, sir.
Centimeters cube. That is all. Just as simple as that. Follow me on YouTube. That's Ninja Easy Mathematics. Ninja is spelled Ninja. You have videos on all the topics, either in elective mathematics or in core mathematics, and study them. Thank you very much. May God bless you.